Hello everyone. Today we'll discuss about one-way multivariate analysis of variance, that is one-way MANOVA. This is our outline. There are three agenda points. What is MANOVA? What are the assumptions of MANOVA? And we'll consider one example of one-way MANOVA. So what exactly MANOVA is? MANOVA is variation of ANOVA with two or more continuous response variables. As we know, in case of ANOVA, we have only one response variable that will be continuous. So there will be one continuous response variable in case of ANOVA. But in case of MANOVA, we have two or more continuous response variables. In MANOVA, M stands for multivariate. MANOVA assesses the statistical significance of the effect of one or more independent variables on a set of two or more dependent variables. So in case of ANOVA, we have one or more independent variables, but there will be only one dependent variable. But in case of MANOVA, we have one or more independent variables and there will be two or more dependent variables. So it's simply ANOVA with several dependent variables. Like ANOVA, MANOVA has both one-way and a two-way types. So this is one-way MANOVA. You can see here one independent variable, that is the factor variable. It is categorical data. So we have taken here educational qualification. There are three levels: graduate, postgraduate and PhD. These are the two dependent variables. One is emotional intelligence and second is job performance. Both the dependent variables are continuous. So this is an example of one-way MANOVA in which one independent variable, that will be categorical, and two dependent variables, and these two dependent variables should be continuous. So what are the assumptions in MANOVA? First, two or more dependent variables should be measured at the interval or ratio levels, that is they are continuous. Independent variable should consist of two or more categorical or independent groups. There should have independence of observations. There should be adequate sample size. The sample size should be large. Number of observation in each group should be greater or equal to 20. Larger the sample size, it will give more robust result. And also it is saying for each level of the independent variable, there should be the number of observations should be greater or equal to 20. Then there should not be univariate or multivariate outliers. Univariate outliers will check through box plot, and for multivariate will check through Mahalanobis distance. Then next, there should be multivariate normality of dependent variable. So it is difficult to find out the multivariate normality. We will check through univariate normality by Shapiro-Wilk, and this significant value should be greater than 0.05. There should be a linear relationship between each pair of dependent variables for each group of the independent variable. So we'll check through the scatter plot. So each pair of the dependent variable will check the independent levels of all the independent variables will check to find out the linear relationship. There is homogeneity of variance covariance matrix. So it will be checked through box M test of equality of covariance, and the box M test significant value should be greater than 0.05. And the last one, there should not be multicollinearity. So the dependent variables to be moderately correlated with each other. So these are the assumptions of one-way MANOVA. Now we are considering one topic. Our topic is a study of educational qualification on emotional intelligence and job performance. So our independent variable is educational qualification with three levels: graduate, postgraduate and PhD, and our two dependent variables are in continuous data: emotional intelligence and job performance. So you can see a scales for data collection. Independent variable, it is a categorical. So educational qualification, 1 is equal to graduate, 2 is equal to postgraduate and 3 is equal to PhD. Dependent variables, two dependent variables we have: continuous data, emotional intelligence and job performance. 1 is equal to very bad and 10 is equal to very good. So and then the numbers between 1 and 10 has the appropriate meaning. Now these are our two objectives. You can see here from our topic we have designed two objectives. First one is to study the educational qualification, emotional intelligence and job performance of the respondents. Second, to study the effect of educational qualifications on emotional intelligence and job performance. So these are our objectives. On the basis of our objectives, we have formulated our hypothesis. The null hypothesis is H0, there is no statistically significant difference of level of educational qualification on both emotional intelligence and job performance jointly. The second alternative hypothesis H1, there is a statistically significant difference of level of educational qualification on both emotional intelligence and job performance joint. So these are our null and alternative hypothesis. Now we have our data. We have already collected our data. So in our data you can see here, this is our data. Educational qualification. So this is our independent variable and it has three levels. 1 means it represents your graduate, then 2 postgraduate, and 3 is equal to PhD. Emotional intelligence and work performance, these are two dependent variables and these their data are in interval scale, 1 to 10 point scale. Now we'll go to variable view and we will put values of educational qualification. 1 is equal to graduate, 2 is equal to postgraduate, 3 is equal to PhD. So we have identified our educational qualification. So it is in our ordinal scale, you can say, because PhD is higher than postgraduate, postgraduate is higher than our graduate. So we'll keep it here as a ordinal data and both these data are in interval. So we'll put here scale. So we have identified our scale for all the three variables. Now we'll go to data view, and in the data view now we'll satisfy our assumptions. So we'll first find out outliers and normality of our variables, dependent variables. So we'll go to analyze. In analyze we'll go to descriptive statistics, then explore, and then we'll bring these two, emotional intelligence and work performance. These are our dependent variable. We'll take these two variables to dependent list, and educational qualification will bring it to factor list, because we want to find out the normality of or dependent variable at each level of independent variables. Each level means graduate, postgraduate and PhD. Now we'll go to statistics. We'll click outliers, then continue. Then we'll go to plots, then we'll remove this stem and leaf, and then we'll click histogram, and then normality plots with test, and then continue, and then OK. So this is our output. This is our output. So directly we'll go to test of normality to see Shapiro-Wilk significant value. We'll go to this test of normality. You can see here test of normality, Shapiro-Wilk significant value, all the significant value at all level for emotional intelligence. You can see here emotional intelligence, graduate, postgraduate, PhD, all the significant values are greater than 0.05. Second, the work performance, for work performance, graduate, postgraduate and PhD, all the significant values are greater than 0.05. So at all levels of independent variable, the dependent variables are normally distributed. Now we'll see the outliers. For outliers we have to see box plot. So you can see box plot for all the three levels of independent variable, graduate, postgraduate and PhD. So there are no points outside these box plots. Here your minimum value Q1, Q2, Q3 and maximum value. So no points are outside this box plot. So we don't have any outliers. Okay. Now we will also check the linearity. There should be the linear relationship between all levels of independent variable and the dependent variables. So we'll go to graphs, we'll go to legacy dialogues, and then we'll go to scatter and dot. In scatter and dot we'll click here matrix and then define. Then we'll bring these two dependent variable, emotional intelligence and work performance, into matrix variable and educational qualification into rows, and then we'll click it. So you can see here this is our scatter plots. So more or less all the scatter plots are here. You can see straight line, this is in straight line, this is in straight line, this is in straight line. if you are going from left to right, all are in the straight line. We will click it. Just a moment. Okay, and then we'll fit a line. You can see here all the lines in a straight line. Somewhere some problem is there, but we can consider all the lines, all the points are in a straight line. So the relationship between the variables with all levels of independent variables is in linear relationship. So this condition also satisfies. Now we'll see the multicollinearity. For multicollinearity, we'll go to analyze, we'll go to correlate, and then bivariate, and then we'll bring these two variables, dependent variables, emotional intelligence and work performance, into variable list, and we will click here. So you can see here the Karl Pearson correlation coefficient between these two variables is 0.583. So it is a moderate relationship. So moderate relationship is required in case of MANOVA between the dependent variables. So our this multicollinearity condition is also satisfying, means the no multicollinearity relationship between the dependent variables, only they have the moderate relationship. So it is okay for our one-way MANOVA. Then we have seen our univariate outliers, but we haven't seen multivariate outliers. For multivariate outliers, we will go to analyze. For multivariate outliers, we will go to analyze, and then we will go to regression, and in regression we will click linear, and we will bring these two dependent variables into independence and our independent variable into dependent list, and then we will click statistics. Okay, in statistics we need not have to do anything. We will directly go to save. In save you have to Mahalanobis distance we have to find out. For multivariate outliers, Mahalanobis distance we have to find out, and then continue, then okay. So directly we will go to the table of this residual statistics. So in residual statistics, Mahalanobis distance you can see here. So the maximum value of Mahalanobis distance is 10.972, but the critical value of Mahalanobis distance for two dependent variables, it is 13.82. So it is less than that. So it is also satisfying. So there are no multivariate outliers. So this condition also satisfies. So all the conditions of one-way MANOVA is satisfying. So now we'll go for the analysis of one-way MANOVA. So analyze, then we'll go to general linear model, then we'll go to multivariate. In multivariate, our dependent variables are emotional intelligence and work performance. So we'll bring these two variables into dependent variables, and our educational qualification is fixed factor, independent variable. Now we'll click here model, in the full factorial, no need to do anything. Plots, you can take educational qualification into horizontal axis and you add it, continue, post hoc, take it right direction, then Tucky test, then we'll go to save, nothing to do here, then we'll go to options. In options we have to descriptive statistics, estimates of effect size, and then homogeneity of tests, and then educational qualification also will take it right direction. Display means for compare means main effects, compare main effects, so LSD, and then continue. Okay, now this is our output. So you can see here graduate, postgraduate, and then PhD, equal sample size. It is one of the conditions for all the levels of the independent variable. The sample size should be same. You can see here the emotional intelligence, mean value, standard deviation, and then sample size for work performance also. Then one of our assumption was the variance, homogeneity of variance and covariance. How we'll test it? Through the box test of equality of covariance matrix. So the significant value of box test should be greater than 0.05, and it is satisfying this condition. The significant value is 0.116, which is greater than 0.05. So it also satisfies the condition. Okay. Now this is our main table of one-way MANOVA. So this is our educational qualification. These are the various tests: Pillai test, Wilks lambda, Hotling. All these tests are there. If all the assumptions are satisfied, then we can see Wilks lambda. If not, then we can go for Pillai test. So we'll go for Wilks lambda. All our conditions are satisfying, so we'll go for Wilks lambda. So value is 0.899, F value is 0.709, hypothesis degree of freedom 4, and error degree of freedom is 52. The significant value you can see here 0.590, which is greater than 0.05. What does it mean? It means null hypothesis is accepted. What does it mean? It means there is no statistically significant effect of level of educational qualification on both emotional intelligence and work performance when we are considering jointly. So this is our conclusion. In this table also, if you want to see individually test of between subject effects, you can see educational qualification, emotional intelligence, the significant value is 0.627. Again, work performance 0.738. So there is no significant difference if you are seeing it individually. And the comparison you can see here in the pairwise comparison, post-hoc test, graduate, postgraduate, all these values, significant values you can see here greater than 0.05. So there is no significant effect of educational qualification on both emotional intelligence and work performance when we are considering together. Okay. Then how to report this data? So for reporting of this data, you can see here reporting of result, that is our output. The Wilks lambda value is equal to 0.899, F value at 4 and 52 degree of freedom, that is equal to 0.709, P value that is equal to 0.590, which is greater than 0.05, and partial eta squared is equal to 0.052. Hence, it has sufficient evidence to accept H naught, that is null hypothesis. It means there is no significant difference between educational qualification when considered jointly on the variables emotional intelligence and job performance. Also, a separate ANOVA was conducted for each dependent variable. Then also what we have found, there is no significant difference between educational qualification on emotional intelligence. As you can see here, the F value, our F value is at 2 and 27 degree of freedom, it is 0.475, and P value is equal to 0.627, which is greater than 0.05, and partial eta squared is equal to 0.034. And the mean value of graduate is 4, M is equal to mean, postgraduate is equal to 4.9, PhD is equal to 4.6. Although you can see here some difference, 4, 4.9 and 4.6, but there is no statistically significant difference. So there is no effect of educational qualification on emotional intelligence. Similarly, there is no significant difference between educational qualification on job performance also. Here also F value at 2 and 27 degree of freedom is equal to 0.307, and P is equal to 0.738, which is greater than 0.05. Partial eta squared is equal to 0.022. And the mean graduate work performance mean value is 3.6. Postgraduate work performance is mean value is 3.5, and PhD mean value is 3. So here also you can see that certain difference is there, 3.6, 3.5 and 3.0, but there is no significant difference. So we can conclude there is no significant difference between educational qualification when considered jointly on the variables emotional intelligence and job performance. So that's it for one-way MANOVA. Thank you very much.